And greetings and welcome. We're talking about last night's homework, page 293, question 37. We were dealing with operations of radicals, adding, subtracting, multiplying, dividing. Today we're actually going to look further into dividing, but at this point we were just doing a little analysis. So let's see. I'm multiplying these two numbers, and the idea is that the coefficients, quote unquote, of these radicals, I can multiply those all normal style. So 4 times 2 is 8. And the radicals, we decided we could multiply when what? What condition had to be true in order for us to multiply the insides? The index had to be the same. So both of these were little invisible 2's there, right? So 18 times 14, 252. So I can just multiply and add them under one big radical. Now the question is, I've combined these. Can I simplify this any further? And I can. So because this is a square root, I'm looking for any perfect square that is a factor of 252. Does anyone know which one that was? Well, let's see. Does 4 go into it? It might. Let's see. 252 divided by 4. It does. And 4 is a perfect square. And I'm left with 63. Does 63 have any perfect squares that go into it? 31 and 3. No. So I'll break this up into the square root of 4 times the square root of, it went in 63 times. So that is in fact the largest perfect square that went into it. And 8 times the square root of 4. Square root of 4 is what? 2 times the square root of 63. So I'll get 8 times 2 is 16 square roots of 63. Let's see, is that the right answer? Oh wait, guys, 9 goes into 63. Right? 9 times 7. Oh man, I just thought of that. That's okay. Well, no, we're good. We roll with it. We live with our mistakes, just like in real life. Think about that. Ooh, that's deep. 9 goes into 63 how many times? 7. So that means, let's see, 8 times 2 times square root of 9 is 3. Someone's excited about 9. 8 times 2 is 16 times 3 is 48. So 48 square roots of 7. Now what that means is, in my original breakup here, let's actually do a parallel universe here. Right, so parallel universe, let's say I continued this problem over here. That means since both 4 and 9 went into that number, that means 4 times 9 went into it and is also a perfect square. Does anyone know what 4 times 9 is as a perfect square?
45.
36. 9 and 5 would be 45. So let's see. And does anyone know how many times 36 must have gone into that? I can cheat. It must have gone in 7 times because 4 times 9 times 7 would have equaled that. So I actually could have broken it down like this. I had 8 times 6 times root of 7. And then 48 roots of 7. So parallel universe, where we didn't make, not the mistake, but just take the longer route, that would have been a quicker way, is always finding the largest perfect square that goes into that. Let's see, 39. Okay, here we're subtracting 2 radicals. All right. What was our rule for subtracting 2 radicals? What had to be true? Or subtracting or adding for that case? What requirements were there? Same index and same what?
The number
radicand. Perfect. All right. So do these have the same index? Yes. Do they have the same radicand? No. So currently I can't subtract them. But let's actually do some work. The cube root of 40 I think I can work with. Cube root, I'm going to rewrite this larger for our internet friends. Cube root of 40, is there any perfect cube that goes into 40? It's a perfect cube. 8, 2 cubed is 8. So I could break that up into the cube root of 8 times the cube root of 8 goes into 40. How many times? 5. That's a wonderful thing right there. And then minus 2 cube roots of 5. Cube root of 8 is 2. So I've got 2 cube roots of 5 minus 2 cube roots of 5. Now I deal with these just like combining like terms, where I'm merely going to add or subtract their quote-unquote coefficients, and the cube root of 5 thing is going to remain unchanged.
Wait, why is there 2 cube root of 5?
Because the cube root of 8 became 2. And this one stayed the same. Right? So, and so if I've got 2 apple pies and I subtract 2 apple pies, how many apple pies do I have? 0 cube roots of 5. And let's see, can you guys do that math without a calculator? 0. Bam. That's how good we are. Look at that. Right? So, but that's the idea is if this was like a 7 minus 2, I would have had 5 cube roots of 5, right? I just merely combined their coefficients. They're kind of coefficients. They're coefficient-y, but they're not really true coefficients. But you know what I'm talking about. 45, I like this problem. This is like a callback to some of the previous skills, and it's going to have multiplying, dividing, nope. It's going to have multiplying and possibly combining like terms in here. Maybe even subtracting. This is going to be awesome. Actually, whoa! You know what I just realized? There's a pattern in this. A minus b times a plus b is a squared minus b squared. But let's pretend I didn't notice that pattern. 6 times 6 is 36. 36. 6 times the square root of 2. Can I multiply those? Like just write that as the square root of 12? No, because this isn't even in a radical, right? So that's just going to be plus 6 square roots of 2. Then I'll have negative square root of 2 times 6. I'll write that as negative 6 roots of 2. And negative root of 2 times the positive root of 2 is the negative, you could call that square root of 2 squared. You could have multiplied their insides because they're indices and indices. The index plural is the same, are the same, whatever. Indices. I think that's probably the coolest way to say it. So that's the square root of 4, which I think you guys know where that's going. Now, combine like terms. Are these like terms?
Yeah.
Why? Same index? Radicand. Same index, same radicand. Perfect. So I've got 6 radishes minus 6 radishes. How many radishes do I have?
0.
0. 0. So 36 minus 2, and this was 0, right? I can combine those. What's that going to be? 34. Man, someday I'm going to be 34 years old. 4 years from now. 3.5 technically. Craziness. Thinking about the finite existence that we all live. That we are all but a vapor, but grass that withers away. Wow. I'll have to, let me set a reminder on my tablet to rewatch this video when I'm 34 on my birthday. I think that would be interesting.
Now everybody on the internet that watches this knows how old you are.
That's fine. They can impersonate me if they
And
want.
what high school did you drive?
Oh, they're narrowing it down. Yeah, they go to the school website. They could find out.
You talk about your apartment all the time, but really close to the school. So
At least I didn't show the Google Map GPS of where I hiked last night on the stream. That would have been bad. Craziness. All right, friends. Thanks for watching.
Have a great day.
And have some radical expressions. That doesn't work
Have
as
a
a
radical
catchphrase.
day.
Have a radical day. I like that. Thanks. Good call, friend.